Hi students, I'm going to do a really quick video with you for you to watch after you have finished your quiz over Kepler's first law. So we're going to work a little bit more with Newton's law of universal gravitation. And what I would like you to do right now is take a second and check to see what your answers are, if your answers are close to the ones that I have given you here. Take a second and do that. Okay, now that you have checked your answers, take a look at these answers and see what happens. As your distance between the two objects increases, what happens to the force of gravity? As the distance between the objects increases, the force of gravity decreases. So hopefully you saw that, and hopefully you saw that in your own calculations. What I would like for us to do is to start doing some conceptual work. It's helpful to know what the calculations are so that you can see the actual numbers before we move into the concepts. The concepts are really more of what we're going to use than actual numbers as we go through Kepler's second law and use Newton's law of universal gravitation to support it. So I'm going to start us out here by looking at two objects. Those objects are exerting a force of gravity on each other. And what we're going to see here is that they have a distance between them. That distance is called d. That's the original distance. What happens if we double that distance? What happens if we double that distance? You can see this in your slides on the next slide. So we're going to look at this. This is our first conceptual problem, and we're going to look at our two objects. The distance between their centers is distance 1, and then we're going to look at those two if they are farther apart, distance 2, and for this we're going to say that distance 2 is double distance 1. So this new distance is double the original distance. So what does that mean? Okay, and we're going to use that the force of gravity is 16, because if we already know what that answer is, then it helps us to kind of figure out, okay, what's going on here. Okay, so if we worked through Newton's law of universal gravitation, if we worked through all of this, we would find that the force of gravity between these two objects is 16 units. And I'm just doing this very generically so that you can see what happens. Okay, but we want to know what the force of gravity is with our new distance between the two objects. So we have a force of gravity 2. Well, that force of gravity 2 has for its distance, instead of the original d, it has an original distance of, or it has a new distance of 2d. So we're going to have our second force of gravity is equal to mg times m1 times m2 over 2d, which is our new distance, squared. All right? We're going to square the 2, and we're going to square the d when we go through this. So we've got our force of gravity 2 is equal to g times m1, m2 over 4. So that's 2 squared, 4, d squared. Okay, so when you square the d, you get d squared. One thing that we can always know is that if we have something here, if we have a value here and we multiply it by 1, it's going to be the same value. So we can always use that truth in mathematics. So I'm going to put a 1 here because that doesn't change anything that we're doing at all. And I'm going to pull the 4 out to the front. So it's going to look like the second, or the new, force of gravity is equal to g times 1 times m1, m2 over 4 times d squared. So if I pull that all the way out to the front, it'll be the force of gravity, the second force of gravity 2, is equal to 1/4 times g times m1, m2 over d squared. Okay? As I keep working through this, I can take this value, g times m1, m2 over d squared. That is what the original force of gravity was equal to, and we said that was 16 units. So if you do this math, for the original force of gravity, it was 16 units. This is the same thing as this original force of gravity. Since they're equal, we can substitute in. All three of these things are equal. Any one of those three things could be substituted in right here where it's green. So what I'm going to do here is I'm going to say that my new force of gravity is equal to 1/4 of my old force of gravity. So when I go through that process, I'll see that if the original force of gravity was 16 units, then my new force of gravity is 1/4 my original force of gravity. Then the new force of gravity is equal to 1/4 16 units. So 1/4 of 16 units is 4 units. So in this case, the new force of gravity decreased to 1/4 of the original. It didn't decrease by 1/4, it decreased to 1/4 of the original. Or the new force of gravity is 1/4 of the original. And that allows us to see that there is a difference, that allows us to see that conceptually we can predict basically what the difference will be between between objects at different places. I would like you to go to your slides and I would like you to try this one on your own and then we'll talk about it in class together.